Hi, I'm Janice Trinidad, and in this video, I'm going to go over how to complete the project rubric section of the project planning form for this training, which you can click to from the table of contents. Just for context, I created these rubrics when I was teaching both 8th grade math and science as separate courses in the same school year. For the project that I'll be featuring in this video, I had the same students for both 8th grade math and 8th grade science. Also, both of these courses were tied to high stakes state tests, so alignment was a key factor in their design. The goal in walking through how I thought through these rubrics is just to show how to write a content rubric that's aligned to standards using positive language, and also how to develop 21st century skills that support the content learning. So let's get started. The first thing that I do when I create rubrics is look at my unit standards and decide which to include in my rubric and what will not make sense in my product rubric. So just for context, in this project, we were doing a roller coaster as our main scenario, and the driving questions for this project in math were: how can we as roller coaster designers use the Pythagorean theorem and linear equations to analyze the distances and slopes of roller coaster tracks? In science, they were: how can we as roller coaster designers use motion concepts, speed, velocity, acceleration, and energy concepts, potential energy, kinetic energy, and conservation of energy, to analyze the performance of roller coaster designs? Some of the broader content questions that were targeted in this project in math were: how can we use the Pythagorean theorem to find the distances between points? And how can we determine and interpret the slopes and y-intercepts of linear equations in the form y equals mx plus b? In science, we were looking at how are speed, velocity, and acceleration similar, different, and related, and how are potential and kinetic energy similar, different, and related. So keeping that in mind, if we look at the standards that were built into these math and science units, you will see that some of them really make sense in this context and some of them don't naturally tie. So what I've done here is I've used color coding to say whether or not I can realistically see that this could show up naturally in a product that goes with roller coaster design and analysis. It's green if that's the case. So in this case, I could easily see how we could have a lot of opportunities to find the distances between points on the coordinate plane using Pythagorean theorem. And similarly for 4C, 5I, 6-8, and 6-8C. So these are things where these are going to show up a lot when we discuss, analyze, and design roller coasters. One thing that was not clear, and there were a couple, is 7C, using Pythagorean theorem and its converse to solve problems. I know from studying that standard that this is mainly about looking at a right triangle and looking at the numbers and trying to use those numbers to decide, is this a right triangle or not? That would not organically connect to this context. So I'm not going to necessarily put that in my rubric, but I'm definitely going to include that in the scaffolding of the project. Another thing I realized that I couldn't put in my rubric and do that standard justice is 6.9C, demonstrate energy transformations such as energy in a flashlight bulb, changes from chemical energy to electrical energy to light energy. So when I look at this standard and how it's assessed, what they're really looking at are kind of qualitative descriptions of how energy changes between 3 to 5 forms that include a variety of different types of energy that don't all show up in a roller coaster. So I know that would look kind of artificial in my product rubric for roller coasters. So I know I'm going to still teach and assess that. I'm just not going to do that in the product rubric. There were some things I labeled here in yellow as possibly things that might show up lightly in the rubric. So for 6C, using models and diagrams to explain the Pythagorean theorem, I thought that might be a good standard to maybe include for advanced. And it could be something they could use where they could use their roller coaster design to justify this explanation. So it's yellow and I'll see if I can fit it. And then similarly, the standard here for A, using similar right triangles to develop an understanding that slope given as the rate comparing the changes in values, et cetera, et cetera. So this standard was looking at using similar right triangles to show that the slope at any 2 points on a line are the same. I knew that this context, this product, would generate a lot of opportunities to maybe verify that in a presentation. So I thought maybe we can include that for advance as well. So just to emphasize, when you have your unit standards, the product rubric isn't the whole project. There's some things that are going to show up in scaffolding and the product rubric, and there's some things that you're not going to have in the product rubric, but you're still going to teach and assess in other ways just because it doesn't organically fit into the context. So once you've got your list of what should be included in the standard, the next thing I start to work on is the proficient part of the rubric. So when you look at the rubrics in this planning form, now that I've picked my standards, I place them on the furthest left so that students and parents and me can see the connections between the product rubric and the curriculum. So I have them all on the left. And then the first thing I like to work on is the proficient column, because what I'm looking for there are descriptions of the product that are at the target level of these standards. So one way to do that, if the standard is very specifically written, is just to use the nouns and verbs in the standard. So an example of that would be these standards here, 4C and 5I. Why these are specific is because they have good verbs that are quite specific. They say the concept, in this case, rate of change or slope. And another thing they include that's not always included in standards is the representation of what they are looking for that standard. So for 4C, they're looking at you applying those skills when you're given a table or a graph. In 5I, they're looking at you being able to write linear equations when the information is given verbally, numerically, in a table or in a graph. So these are very specific teaks. That clarity gives me the confidence to start writing the proficient rubric. So in this case, for my roller coaster, I'm looking at using data from a table or graph to determine rate of change, which is in 4C, or slope. Also to use that same data to solve for the y-intercept, which is also in 4C. And then to use the results from those two skills to solve for equations in the form y equals mx plus b. Another thing to do, so not all standards, unfortunately, are written as specifically as these. So one thing I had to do specifically in the science curriculum is to look at district resources to understand what does this standard mean. So for example, 6.8a, compare and contrast potential and kinetic energy. I've taught physical science at many different grade levels, so this for me is quite vague. It doesn't give me the representation. It doesn't tell me if we're looking at real world examples, textbook examples, tables, graphs, numbers, are we calculating things? So in this case, I had to go to district resources to get a better understanding of what this standard means at this grade level. So in this case, what my district had for me, and every district will have different resources, were actual state release questions that go with each standard. So I was able to download these. At your district, you may have this by standard, or you might have a similar kind of record that further unpacks what's in that standard. If you're really not sure if the standard's written vaguely, I would take a look at these. So when I took a closer look at what this could mean at grade 8, what they were really looking at was a more qualitative understanding of potential and kinetic energy. So when they're comparing, they're not actually calculating, they're actually looking at scenarios and trying to pick out maximum kinetic or maximum potential energies. And they'll also give scenarios and they'll have you compare different potential energies and kinetic energies given descriptions of what's going on in that scenario. At no point in any of these assessment questions did they ever have to calculate, which I found odd. And just to verify that, I looked at the reference materials they would be using on the state test, and sure enough, there are no energy formulas there. So I knew that if I were going to write the proficient standards for that standard, it wouldn't be necessarily from an equation standpoint, it would be more of a qualitative standpoint. So the way I wrote that for the roller coaster is to reach this target level, they should be able to compare the positions. They should be able to use positions or speeds to rank all the kinetic energies at the different parts of the roller coaster from least to greatest. And they should similarly be able to compare positions to rank the potential energies from least to greatest. And they should be able to use changes in direction or speed to describe whether that change just goes with potential to kinetic energy or kinetic to potential energy. Once I have my proficient done, the next thing I look at is either the left column or the right column, developing or advanced. For the sake of this video, I'll just go over the developing column first. So for the developing column, the way I like to think about that is, what do my students already know when they're going into this project that I can build on so that they can get to proficient? So this is a spiraling opportunity, and this is an opportunity to be very clear with your students that they come into this project with skills that are connected to the work they're about to do, and that they're going to be reinforced by reaching the targets in this project. So one way to do that, in this case, I was their math teacher. This project was done midway through the year. We had spent a tremendous amount of time, 2 or 3 projects on order of operations. So you'll see in my math rubrics here, all of my developing criteria have a connection to order of operation. So for 1.1, shows evidence of using correct order of operations to simplify and solve for values plugged into Pythagorean theorem. So it may be when they come into this project, they may be getting answers wrong because they're putting in the values into the Pythagorean theorem incorrectly. However, once the numbers are there, they may show evidence that they can still simplify, even though they arrive at the wrong result. So that would be a sign that they're on their way to getting to that target skill, and they're using their prior knowledge to develop that knowledge. And you'll see that kind of trend for all of their other calculations in the rubric. And I also included that because I knew order of operations is a tricky skill. So it gave me opportunities to continue to reinforce it in this project, even though we'd already covered it in previous units. Another way to pick your developing criteria is from just your knowledge of what students understand of the material from prior conversations. So in science, I knew by the time I got into this project that most of my students already associated kinetic energy with speed, and they associated potential energy with position. So in this case, my developing notion is, can they explain the motion? Can they use motion to explain which parts of the roller coaster have the most kinetic energy? And similarly, can they use the height or position of the roller coaster to explain which parts of the roller coaster have the most potential energy? So those are starting notions for how to describe it. It's not quite fully there, but at least it's playing off what I know that they can discuss. And we're going to build on that to get to the level of understanding they need for this project. So that is developing. For advanced, I'm trying to look for criteria that's not just more, not necessarily more, but deeper in learning. So one way I like to think about that is, can the students make effective connections between big ideas that are actually helpful? So for example, in my advanced criteria for the section on slope y-intercept and slope-intercept equations, I have used diagrams with the line and multiple similar right triangles and properties of similar right triangles to explain why slopes are the same for any 2 points on the line. The reason why I think this is advanced is because they're having to connect the properties of similarity proportions to lines, which are they're very different big ideas, but they're very connected. And they're using those connections in order to get at a really fundamental property of lines. So if they can make those connections, that's a sign of deeper learning, because they're connecting 2 big ideas to reinforce something important about the properties of lines. Another example of making effective connections would be in my science rubrics, I have uses rates of change slopes on roller coaster distance time graph to compare speeds on different parts of the graph and justify comparison. And then I have a similar one for them doing that on the velocity time graph. The reason that is advanced in this case is they're connecting something I taught them in their math class to something they're learning in their science class. And for that to be an advanced thing, what I'm looking for there is that they're making that connection to say to make better comparisons, more sound and confident comparisons on their graphs, because they're able to see by thinking of those rates of change as real quantities, they're able to say some real things about the graphs while also connecting the knowledge into different courses. Another way to get it advanced, and I don't do this all the time, but I had a good reason to do it in this project, is to incorporate expectations from the next level of the course. In this case, I also teach 9th grade science, where we look at energy again. In 9th grade science, unlike 8th grade science, we actually use potential energy, kinetic energy, and conservation of energy formulas. So I decided to include these as advanced for this project. The reason why I decided to make that call is because I noticed that the calculations that they would do in this, for these standards, when they calculate potential energy, kinetic energy, and make predictions using conservation of energy to find missing energies, speeds, or heights, all of these involve math skills that they really need for the 8th grade math course. So all of them incorporate similar solving skills that go with solving Pythagorean theorem type equations or rearranging linear equations in order to solve for a missing variable. So this is, again, creating more opportunities for me to reinforce some math skills. Another good reason why I decided to go ahead and include these expectations for the next year's course is because for this particular group of students, I had quite a wide range of students' skills coming into the course. And I knew there are enough students at that higher level that I needed to give them something to do, while some of the students that were not quite advanced were catching up. So that gave me something that would take them time. And I also knew from those students it would give them something that they would appreciate, because then they would be able to kind of verify these qualitative comparisons by actually doing the calculations. But again, using standards from the next course, use that. If you're going to do that, use it guardedly. And the way I know it's appropriate to do that is if it reinforces a useful skill that they need for the current year, and if you know you have kids that can handle it. So those are my 3 columns. That's my thinking around the 3 columns. Once I have my content rubrics written, I start to think about my 21st century skills rubric. Notice how short my rubric is, and that is for good reason. When I'm picking my 21st century skills rubric, I have to bear in mind, I need to teach all this content and also make sure I have time to teach this 21st century skill in a way that supports that content learning. So what I'm looking for 21st century skills are things that I know that if the students practice the skill, they're also going to be reinforcing their content knowledge. So when I'm doing this, one bit of advice, because we're very busy people, is don't reinvent the wheel. There are dozens, there are a lot of rubric resources online. In your actual project planning form, there's a link to the rubrics that I use. And these are not, I'm not saying you have to use these. The reason why I use these is because I belong to this network. My school belongs to this network. So our grading system is tied into these rubrics. In your district, you may have your own district rubrics that go with this. If you're not required to use a specific rubric, you can just Google 21st century skills rubrics and come up with something. In this case, if you use the resource that's linked in your project planning form, you'll see there's 5 21st century skills, and you can pick the appropriate grade level. I knew that knowledge and thinking, which is just another way of saying critical thinking, would be really critical in this project. And I'm familiar with these rubrics, so I knew the math section, one of the math problem solving rubrics would have something very useful. So when I open the math problem solving, so this is critical thinking as it appears within a math course. After looking through this rubric, the thing that really connected with me for this particular project was the strand here that has to deal with multiple representations. So here they're looking at how else can students use different representations of ideas in order to make arguments and demonstrate ideas. I thought that would be really critical to this project because in my math standards, we're required to represent slope, y-intercept, and linear equations from verbal, numerical, tabular, and graphical representations. So I knew in order to teach that standard well, we would have to be using a lot of different representations for the same idea. Having this in my 21st century skills rubric would just allow me to really emphasize the idea. It's not so much, can you do this from a table? Can you do this from a diagram or graph? It's that you need to know how to do all of it and then express and communicate from all those representations. And then similarly, I knew they were going to be presenting at the end of this project and throughout this project. So I picked a strand of the oral communication rubrics that would reinforce this idea of multiple representations. So what I picked was the clear presentation of ideas. The reason why I picked these ideas is it looks like, again, I was looking for consistency across the board and clarity. So I like how this particular strand of oral communication emphasizes clear communication of ideas either occasionally or most of the time, and whether or not the audience is able to understand your argument. So now that I have picked out my 21st century skills rubric, the last thing I do is I try to make this kid friendly. It's not obvious. I'm going to point out the features that are in here that make this kid friendly. It did not look like this when I was first drafting it. First thing is I only have these highlights in for the purpose of discussion. So for a kid friendly rubric, I'm going to give it to them unhighlighted. The reason being is they're going to highlight it themselves to see how their product and their understandings are coming along. Another thing I've learned to do is to limit my rubrics to 1 page. So you'll see I have 1-page rubric here for math, another page rubric here for math. So what I'm thinking here is I'm going to divide my project into 2 phases. One that will emphasize Pythagorean theorem and the distances between points. And then I'm going to have another project phase that's going to emphasize slope, y-intercept, and slope-intercept equations. And I will give the students this rubric 1 page at a time at the appropriate moment in the project. So they might see both these rubrics in the entry event, but we are going to start highlighting and really unpacking each part at the right time. And I want to be able to hand it to them 1 page at a time. And I did something similar since I knew I was going to have this 2-phase structure in the math class to mirror that in the science class. I divided up my rubric into 2 sections, a 1-pager that emphasizes potential and kinetic energy. And again, I would unhighlight that. And then a 1-pager that emphasizes motion calculations and motion graphs. Another thing that that makes this kid friendly for my kids is these were originally, when I was drafting it, were in bullet form. I replaced those bullets with reference numbers. So that way it would be easy for me and my students to communicate like what part of the rubric we're discussing without having to read out loud the whole bullet point. We could reference them using the rubric labels. And another thing I did to make this a tool that my students could use is I try to limit each rubric criteria to 1 skill. So for example, here I have calculating slope as 1 item, solving for y-intercept as another item, and then using those results to find the linear equations as a separate item. The reason why I like to have these separate is so that way when I'm giving feedback, or if the students are giving feedback to themselves or their peers, they can say something like, you're really great. You're on track here. Your product shows evidence that you can find your slope, and your product shows evidence that you're finding your y-intercepts. However, you're making some errors when you're substituting those values in the equation, so that's yellow. So if you make those skills a little more discrete in your rubrics, it'll be easier for your students to self-assess what parts of the skill am I really understanding and demonstrating well in my product, and where are my next steps lie. Also, coincidentally, while I have these highlighted, this is what one of the ways I have my students self-assess, or how I give feedback to my students, is if I see solid evidence in the product, I will highlight it green. If it's on its way there, I will highlight it yellow. If I can't find it, I might highlight it more something on the redder section. If I can't see the work, and so on. Finally, when you're done with your plan, another tool that's in this resource that can help you self-evaluate is the rubric reflection. So over here, you'll see a section of the project challenge rubric for this training that goes specifically with designing these rubrics. I went ahead and rated the rubrics I put in here for this example according to this rubric and justified it. And again, while I'm reinforcing that this is something I would have my students do, they would look at the rubric, highlight it according to whether or not they thought they nailed it, or if they think it needs more work, and then explain it with text on the side. If you would like to look closely at this rubric, because I know this was a quick overview, you can find this ideation form and rubrics at bit.ly/Trinidad, capital PPF, and that is just the abbreviation for project planning form. I hope that was helpful.